Hello. Today we're going to look at section 9.4, part 1, graphing trigonometric functions. Today we're going to focus on the sine function. Next week we'll take a look at the cosine function. Let's start with a few definitions. A periodic function is a function that repeats. And you'll see sine and cosine are both examples of periodic functions. The amplitude of a periodic function is the distance from the center of the graph, which is often called the midline, to a peak, to either the top, the maximum, or the bottom or minimum. We're going to abbreviate amplitude with a capital A, unless you want to write out the word amplitude every time. If you want to write out the whole word, feel free. The period of a periodic function is the length of one horizontal cycle. So from a maximum to a maximum or a minimum to a minimum, I'm going to abbreviate period with the capital letter P. The vertical shift is the same as a vertical translation. So this is how much our graph is shifted up or down. The nice thing about our vertical shifts is it's going to give us our midline. It tells us where the middle of our graph is. And I will abbreviate vertical shift with capital VS. And phase shift is the same as a horizontal translation of shift. And this is going to give us our starting point, or it's going to affect our starting point, I should say. And I will abbreviate that with capital TS. The parent function, y equals sine x. Our labels on the x-axis, we have pi over 2 pi, 3 pi over 2, and 2 pi. Same thing, but negative on the other side. Now, if you recall from last week, we saw that I'm throwing papers on the ground even when I'm at home. We saw that sine of x was equal to y over r. And if we tie this back to our unit circle, right, the radius would be 1. And y divided by 1 is just y. Okay? So on our unit circle, the y-coordinate of any point on our unit circle is going to equal the sine of our x-coordinate, of our angle. So if I go to my unit circle, all right, and at 0, my y-coordinate here is 0. So we have a point at 0, 0. If I go to an angle of pi over 2, my y-coordinate here is 1. So at pi over 2, my y-coordinate is 1. At pi, my y-coordinate here is 0. And at 3 pi over 2, if we think about a y-coordinate at this point here, it's going to be -1. 3 pi over 2, we're at -1. And then at 2 pi, we're back to a y-coordinate of 0. Now also recall that we get our negative angles by going down from the x-axis. So if I go this way, negative pi over 2 is the same as 3 pi over 2. Those are coterminal angles. And at negative pi over 2, my y-coordinate would be -1. And you might be seeing a pattern here that we can use to continue our graph. All right, so there's the graph of our parent function, y equals sine of x. Our amplitude, okay, the distance from our midline to a peak, well, from the middle of our graph to either our maximum or to our minimum is 1 space. So the parent function has an amplitude of 1. The period, the length of one cycle. Now be careful because it's tempting to say that it might just be pi, but here, all we have is from the middle to the maximum back to the middle. We haven't included this whole piece here. So from here to here is 1 complete cycle. So that's a period of 2 pi. And on this particular one, we do not have any shifts. So our midline is the x-axis, or the line y equals 0. And just for a little bit of review, our range, the y-coordinates that are included on this graph, are all in between -1 and +1. So this is always true about our parent function. Now the real fun is taking a look at transformations of this parent function, right? Because any function we graph, we're then going to look at our transformations. That's been our pattern all year. It's not stopping now. All right, so to graph a trigonometric function, we're going to start by identifying our amplitude, period, phase shift, and vertical shift. The second thing we're going to do is divide the period by 4 to get our x-axis scale. And we're going to use our phase shifts and vertical shifts to determine our starting point. Does our graph start at 0, 0, or if it's been shifted, where's the new starting spot? And we're going to plot 5 points. And notice that when we did this, we started with the midline. Then we went up to our maximum. We came back to our midline. We went down to our minimum. And then back to the midline. Those 5 points gave us one complete cycle. And then we can connect those 5 points to form our curve. All right, so let's see if we can use that process to graph some examples. We're going to do quite a few examples, and feel free to skip ahead to more complicated ones if these friendlier ones are things that you don't need to see. All right, so notice that we have a 5 out in front. Now, before talking about trigonometric functions, we would have just said, hey, this has a vertical stretch by a factor of 5. All right, so if I ask you to describe transformations, you can still do that the exact same way we've described transformations all year long. I totally skipped something. Whoopsie daisies. I can fit it over here. Sorry about this. The general form of a sine function is going to look like this. F of x is equal to a times the sine of b times the quantity x minus h plus k. Now this number in front is going to tell you your amplitude, right? That's your vertical stretch or shrink. If you multiply by a number inside, okay, after the sign, that would be our horizontal stretches and shrinks, and that's going to affect our period. And to find our period, we'll do 2 pi divided by that b value, that number in front of x. H, that number that we add or subtract inside the parentheses, is going to be our phase shift. All right, so if it says minus something, it's actually going to move our graph to the right. If it says plus something, it would move our graph to the left. And if we add or subtract a number outside of our parentheses, that would be our vertical shift. Remember, that behaves normally, so if it's plus, it's going to shift up. If it's a minus, it's going to shift down. All right, so now that we have that in mind, okay, I know that this 5 that's in front of the sine is my amplitude. My period. I don't have a number written in front of the x. I could say there's a 1 there, so if I do 2 pi divided by 1, right, 2 pi divided by the number in front of x, I get 2 pi for the period, and we don't have any phase shift or vertical shift for this one. All right. So we've identified our amplitude, period, phase shift, vertical shift. Now we're going to take our period and divide it by 4. So 2 pi divided by 4 . 2 over 4 is the same as 1/2. So we get half of pi, or pi over 2. So our scale on this one will actually match the scale on our parent function. So my first mark is 1 pi over 2. My second mark is 2 pi over 2, or that's the same as 1 pi. My third mark is going to be 3 pi over 2. And my next one is going to be 4 pi over 2, where 4 over 2 is the same as 2 whole, so 2 pi. All right, so we've labeled our x-axis with the scale. Since we don't have any phase shift or vertical shifts, our starting point will just be at 0, 0. Okay, so there's our first point on the midline. We know our next one is our maximum, and because our amplitude is 5, we're going to go up 5 spaces. Our third point should be on the midline. Our fourth point should be at the minimum, and because our amplitude is 5, we're going to go down 5 spaces from the midline. And we're back to our midline. And you can repeat the pattern on the opposite side to extend your graph. It should look just like our parent function, but with that vertical stretch of 5. So this time, instead of having all of our points being in between -1 and +1, they're in between -5 and +5. Next up, we're going to graph f of x equals the sine of x plus 3. Notice that because this plus 3 is not inside parentheses with the x, this is a vertical shift. Up 3 spaces. Okay. Our amplitude, well, the number we could say is in front of our sine would be 1. So amplitude is 1. Period. We could say there's a 1 in front of the x, so 2 pi divided by 1 is still 2 pi. This time, there's no phase shift, but we do have a vertical shift up 3. All right, so since our period's the same as last time, it's going to have the same scale of pi over 2. So 1 pi over 2, 2 pi over 2 is pi, 3 pi over 2, 4 pi over 2 is the same as 2 pi. Okay. Normally the graph of sine starts at the point 0, 0. Okay. But because we have a vertical shift up 3, our starting point will be at 0, 3. Some people find it helpful when there's a vertical shift to draw on a bit of a dashed line to help them see the spaces that are going above and below that line. You don't have to, but you can. Okay? All right. And next we're going to plot our 5 points. So we have our first point on our midline. I forgot one thing here, huh? On our first example, our midline would still be at y equals 0 on this one. But on this graph, our midline is y equals 3. That's that line that we just kind of dashed in there. All right, so our first point's on the midline. Our next point is going to be the maximum. Since our amplitude is 1 this time, that just means we're going up 1 space from our midline. Our third point should be on our midline. Our fourth point should be at our minimum, and since our amplitude is 1, that's going to be 1 space below. And then back to our midline. And you can continue the pattern on the other side to complete your graph. Notice this time our range, the y values that are included on this graph are in between positive 2 and positive 4. 2 is our smallest y value. 4 is our highest y value. On all of these, our domain is all real numbers, right? We can put in any angle and be okay. All right, I'm going to turn my paper over. All right, amplitude, the number in front of the sign, we could say is 1. Period. Well, we have this 2 in front of our x. And if you recall, I should have written this in already. Okay, that's our horizontal stretches and shrinks, and they act a little backward. So multiplying by 2 is not a stretch when it's horizontal. It would actually be a horizontal shrink of the reciprocal of that, so 1/2. To find our period, we do 2 pi divided by our b value. So 2 pi divided by 2 is going to give us 1 pi. And we don't have any shifts in this case. Next up, we want to divide our period by 4 to get our scale. So our period is pi. Divided by 4 is just pi over 4. So my first mark here is going to be 1 pi over 4. My next mark is going to be 2 pi over 4. Well, 2 over 4 is the same as 1/2. So this is pi over 2. My third mark would be 3 pi over 4. And my fourth mark would be 4 pi over 4. Well, 4 over 4 is 1 whole, so 1 whole pi is pi. Okay. We don't have any shifts, so our starting point is going to be 0, 0. Which means our midline will be y equals 0. All right, so our first point's on our midline. Our next point's going to be at our maximum, and since our amplitude is 1, that's 1 space above. Back to our midline. Then we have our minimum 1 space below. Back to our midline, and continue the pattern on the opposite side. Connect our points to get our curve. And this time our range, we have y values in between -1 and +1. Okay. Number 4, example 4 here, f of x equals the sine of the quantity x plus 2, since that plus pi over 2 is inside the parentheses. We know this is going to be a horizontal shift. And remember, those are backwards, so if it says plus, it actually moves our graph to the left, so we have a shift left, pi over 2. Okay. We identify our amplitude, period, phase shift, vertical shift. A, our number in front of sine, would be a 1. Period. The number in front of our x we could also say is 1, so our period 2 pi divided by b, 2 pi divided by 1 is 2 pi. We have a phase shift, left pi over 2, and no vertical shift. Our scale, take your period 2 pi and divide it by 4, which we saw earlier, that's the same as pi over 2. Sorry, a little bit off the screen there. All right, so my first mark is at 1 pi over 2. My next mark, 2 pi over 2. 2 over 2 is the same as 1 whole, so 1 pi. My third mark would be 3 pi over 2. My fourth mark, 4 pi over 2, is the same as 2 pi. All right, so that was step 2. Step 3, we want to determine our starting point. So normally it's at 0, 0, but because we're being shifted left pi over 2, that's going to be negative pi over 2, comma 0. Since we didn't have a vertical shift, our midline is still y equals 0. And now we can start plotting our points. So we have our first point on our midline. Our next point is our maximum. Since our amplitude is 1, that's 1 space up. Back to our midline. Our next point is going to be at our minimum. And since our amplitude is 1, that's 1 space below the midline. Back to the midline, then our maximum. And you can continue the pattern to complete your graph. And here our y values are again in between -1 and +1 for our range. So in those first 4 examples there, all of the graphs had just a single transformation, either a change to the amplitude, a change to the period, a change to a phase shift, or a vertical shift. I'm going to do 3 more examples that combine these. If you need to continue watching, please feel free to do that. Otherwise, if you feel like you can put this together on your own, then do that as well. Okay, whatever you need. All right, so if I was going to describe my transformations, in example 5 here, g of x equals 2 sine x minus 1. We're multiplying by 2 out in front, so that would be a vertical stretch of 2. And the minus 1 is not inside parentheses, so that would be a vertical shift, so we have a shift down 1. All right, our amplitude, the number in front of sine is 2. Our period, 2 pi divided by our b value, 2 pi divided by the number in front of our x, we could say is 1. So 2 pi divided by 1 is 2 pi. And we have a vertical shift down 1, no phase shift. Our scale, our period, divided by 4, 2 pi divided by 4, we've already seen is pi over 2. A little squished on that side there. All right, so 1 pi over 2 pi, 3 pi over 2, 2 pi. All right, normally we have a starting point at 0, 0, but because this graph is being shifted down 1, our starting point is going to be at 0, negative 1. Again, if it helps you to draw in your midline, feel free to do that. So our midline is the line y equals negative 1. And now we're going to do our 5 points. So our first point's on our midline. Our next point's going to be at our maximum. Because our amplitude is 2, we're going 2 spaces above our midline. Our third point's on the midline. Our fourth point is at our minimum, and because our amplitude is 2, that's 2 spaces below the midline. And we're back to our midline. You can continue the pattern. And notice this time our y values are all in between -3 and +1. So our range is in between -3 and +1. All right, example 6, g of x equals the sine of the quantity x minus pi over 2 plus 1. So since this is being subtracted inside the parentheses, that's a horizontal shift. And remember, that horizontal is backwards. If this is minus, that's going to shift us to the right. And the plus 1 outside the parentheses is going to be a vertical shift. So up 1. Amplitude, the number in front of our sign, we can say is 1. Period equals 2 pi divided by the number in front of our x. Well, hey, that's also 1, so 2 pi divided by 1 is 2 pi. We have a phase shift of right pi over 2 and a vertical shift up 1. Our scale, since our period is 2 pi divided by 4 gives us pi over 2. All right, so pi over 2, pi, 3 pi over 2, 2 pi. Okay. So normally sine starts at 0, 0, but we have some shifts. So we're going to be shifting right pi over 2 and up 1. So our starting point is positive pi over 2, comma 1. If it helps, you can add in that midline. So this time our midline is at positive 1, so y equals 1. And now we're going to graph our points. So our first point's on our midline. Our next point should be at our maximum, and since our amplitude is 1, we're going one space above our midline. Our third point's on our midline. Our fourth point is at our minimum, and with an amplitude of 1, we go one space below that midline. Our next point would be on the midline. Continue the pattern to complete your graph. We try to show at least 2 complete periods on these trigonometric functions. So this time we have y values that are in between 0 and 2. We're going to do one more example if you're still following along. This will be the last one. This time we're going to graph g of x equals 3 sine 1/2 x minus 2. If you were going to describe the transformations, multiplying by a number out in front gives us a vertical stretch of 3. Multiplying by 1/2 on the inside is horizontal stretches and shrinks. Remember, those are backwards. So multiplying by 1/2 actually gives us a horizontal stretch by a factor of the reciprocal of 1/2 is going to be 2 over 1 or 2. And then we have a vertical shift of down 2. So our amplitude, our number in front of the sign is 3. Our period, 2 pi, divided by our coefficient here, 1/2. Well, if you have 2 pi and you divide them into halves, you're going to get 4 pieces of pi. Here's my little scratch paper here. Also, 2 pi divided by 1/2. If you recall, when you divide by a fraction, you multiply by the reciprocal. So that would be 2 pi times 2 over 1. 2 pi times 2 is 4 pi. Over 1 times 1 is 1. 4 pi divided by 1 is 4 pi. So however you like to think about it. Okay. We have no phase shift, but we have a vertical shift down 2. All right. For our scale, we take our period and we divide it by 4. So 4 pi divided by 4 is going to give us 1 pi. So the first mark on the x-axis is going to be 1 pi. My second mark will be 2 pi. My third mark will be 3 pi. My fourth mark will be 4 pi. Oh, slide that up so you can actually see. There we go. All right. Step 3, we're going to determine our starting point. And remember, for sine, it's normally at 0, 0, but because we have a shift down 2, our starting point is at 0, -2. And if it helps you to sketch in your midline, you can. So our midline is the line y equals -2. And to graph our points, we have our first point on our midline. Our second point should be at our maximum, and since our amplitude is 3, we're going to go 3 spaces above our midline. 1, 2, 3. Third point's on the midline. Fourth point should be our minimum, so 3 spaces below our midline. Back to our midline, and then you can continue the pattern. And connect your points. So this time our lowest y value is at -5. Our highest y value is at +1. So our range is from -5 to +1. Please reach out if you have any questions. I'm here to help you. Good luck with your assignment.